Next, we're going to talk about the factors that affect the chemical reaction rates. The first one being the chemical nature of reactants. So in your lecture outline, there is a video link to a YouTube video that shows 3 different alkali metals reacting with water. And we see different reactivity. So give that video a look. It's about 3 minutes. It's really, really cool as well. All right, the second factor is the surface area of reactants. So in both of these pictures here, we have iron reacting with hydrochloric acid. In this video to the left, iron is in the form of a powder, whereas here, this is an iron nail, right? You can kind of see in there, it's an iron nail that's reacting with hydrochloric acid. So it turns out the iron powder reacts faster because when the iron is in the form of a powder, right, more surface area of the reactant is exposed to the hydrochloric acid, thereby being able to react. So we see this hydrogen gas that is coming off of, that is one of the products that's formed as a result of this reaction. Whereas with the iron nail, it is much slower than the iron powder. So surface area, more increasing surface area by reactants will typically increase our reaction rate. The third factor is the temperature of reactants, right? If we increase temperature, we end up with the reactants, the kinetic energy increasing, right? Moving around more collisions, therefore the reaction rate increases. So increase in temperature usually increases the reaction rate. Fourth factor is the concentration. So if we increase the concentration of one or more of the reactants, we'll also see an increase in the reaction rate because we have more reactants that can be consumed in the reaction. So here's an example. This is a statue that shows normal, well, doesn't show normal weathering. It actually shows what happens where so different statues that are made up of calcium carbonate, right, will have normal weathering, but in a polluted atmosphere where sulfur dioxide is high, the calcium carbonate in the statues deteriorate faster, right? So this is an example of an increase in concentration, which will increase the reaction rate. In this case, increase deterioration of this statue. The fifth factor, and the last one that we'll talk about, is the presence of a catalyst, right? Because a catalyst's whole purpose is to speed up a chemical reaction without being consumed in the reaction itself. We'll talk more about this next week. We'll talk more about catalysts specifically next week. So a quick example of a catalyst, which is really cool. So turns out hydrogen peroxide decomposition is a slow like it has a slow reaction rate, right? Just in terms of it decomposing on its own. But in the presence of a wound, right? If any of you have ever, fell and got a wound, and your parent or you may have put hydrogen peroxide on that wound and you see these bubbles form, right, which is oxygen gas, something in the wound, there is some chemical within the wound that actually speeds up or that acts as a catalyst that increases the rate of the reaction. So then the hydrogen peroxide actually decomposes faster in the presence of a wound. Yep, as you said. Decomposition of hydrogen peroxide is normally slow. It's sped up in the presence of a wound. Wound. I don't know why I like to say the word wound, but it's wound. Okay. We're going to pause here and in the next video talk about rate loss.